Okay, this is question 6 from exercise 2.08, direct linear variation. Now, remembering our 4 steps, we will write for direct linear variation. Our first step is y equals kx. Remember, if there's a direct linear variation, then we'll substitute x and y to find k, and then we'll write the equation out with the value of k now that we know it, and then we'll answer the question. So let's look at question 6 here. It says the download time t seconds of a computer file is directly proportional to the size of the file, s kilobytes. So time is in seconds, s is the size. On Jay's computer, a file of 1,800 kilobytes requires 36 seconds to download. Find the variation relating t to s. So we know that t equals k times s, because it's directly proportional, or it's a direct linear relationship. We know that when t, we know 30 is 36 seconds, the size of the file is 1,800 kilobytes. Okay, so we'll substitute that in. So we're going to sub those in. 36 equals k times s is 1,800. So remember, our first step is to write out the equation. The second step is to substitute some values of x and y. In our case, they're values of t and s, and that will help you find k. So k is 36 divided by 1,800. Just putting that on your calculator as a fraction, we get 1 over 50. So therefore t equals k is 1 over 50 times s. Now that's 1 times s over 50. In other words, t is s divided by 50. So that is our equation. T is s divided by 50. All right, part B. So that's our variance equation relating t to s. Part B, how long will it take Jai's computer to download a 3,000 kilobyte file? So they're asking about time. Time is question mark if the size of the file is 3,000 kilobytes. So now that we've formed an equation, we've got t equals s over 50. We're going to substitute s is 3,000. So t is 3,000 over 50, and the time is, that looks to be 60, and the units are seconds. Okay, so it will be t is 3,000 over 50, which is 60 seconds. And part C of the question says that a file took 80 seconds to download. What was its size? So if time is 80 seconds, the size of the file is question mark. Again, write out the formula. T equals s over 50. We're substituting t is 80, is s over 50, and to work out s, it will be 80 times 50. So therefore the size of the file is 4,000 kilobytes. Okay? All right. Okay, now for question 12 in the same exercise, 208. At 3:30 p.m. one day, the shadows of different objects were measured, and they were found to be directly proportional to the heights. So we can see that the shadows are directly proportional to the heights of the objects. Okay? Now it says a tree of height 250 centimeters has a shadow of 325. So let's let the height be h in our equation, and the shadow we're going to represent by s. Okay, and it's, so we know that the shadows are directly proportional to the height. So shadow equals k times height. So you have to read the question out, and it says the shadows are directly proportional to the height. So you start with shadows equals k times the height. Okay. Now we know that when the height of the tree is 250, the shadow is 325 centimeters. Okay. So they're all in centimeters. So we need to substitute that in. So remember our 4 steps. Step 1 is to write the equation. Step 2 is to work out what k is. So you can only work out what k is if you know a value of h and s at the same time. So in this question, they're not guiding you. They're not telling you to write this equation out, work out k, and all that. Okay, you have to do that yourself. So we've got s, which is 325, equals k times the height is 250. So 325 divided by 250 equals k. And that's exactly 1.3. So k equals 1.3 or 13 over 10. Okay, I'm going to probably write this one as 1.3. Okay, so therefore we know the formula is S equals K times H, or it's S equals 1.3 times H. Okay, now we're still working on part A, and the question says, what is the length of a shadow of a lamppost with height 320? So now the question is, when H is 320, S, find S, or S is question mark. So S, so this is part A, S equals 1.3 times 320. So 1.3 times 320, which is 416 centimeters, because the units are centimeters. And part B, the question says, what is the height of a letterbox correct to the nearest centimeter if its shadow is 1.11 meters long? So they're saying that the shadow is 1.11 meters, and they're asking for the height of the letterbox. So remember, these units are different to everything else used in the question. So let's change these to centimeters. So that's 110 centimeters. So the shadow is 110 centimeters. Find the height. We know that the equation linking shadow and height is S equals 1.3 times H. We know in this case that S is 110. It's 1.3 times H. So therefore H is 110 divided by 1.3. So H is 110 divided by 1.3, which is 84.615 centimeters. They want the height of the letterbox to the nearest centimeter, which is 85 centimeters. Okay? So just noticing the height is smaller than the shadow in that question. Again, the height 320 is smaller than the shadow of 416. In the original question, the height is smaller than the shadow. So that is how it's proportional. You don't want all of a sudden in some of your calculations the height being bigger than the shadow, because then you would have done something wrong. Okay, so in these questions, notice they're not asking you to find the formula. But however, when you're asked, when you've got questions that say it's directly proportional, you must start with the first step, y equals k times x, and then you will substitute a value for x and y to find k. That's always substitute x, y to find k. And once you know what k is, you then put the k back into the equation, and then you'll sub that value of k back in. You'll have y equals some value times x. Right now it's not always y and x, so you need to change them, and I'd be changing them first up at the beginning of these questions. Okay, just looking at a HSC question, this 2014 HSC question 26F. The weight of an object on the moon varies directly with its weight on the Earth. So weight on the moon, so we'll go moon equals k times weight on Earth. Okay, remember it's of this form, y equals kx. So the weight of an object on the moon varies directly with the weight on the Earth, m equals k times e. Then they will give you some information. An astronaut who weighs 84 kilograms on the Earth, so when e is 84, they on Earth they only weigh 14 kilos on the moon, so moon is 14. So we substitute that in. So 14, so when e is 84, m is 14. So 14 equals k times e, or k times 84. In other words, k is 14 over 84. And you can simplify that on your calculator. So 14 fraction 84 is 1/6. So therefore the formula is m equals k times e, which is m equals 1/6 times e, and it's best to write that. Now 1 times e is e, so that's e over 6. That's your formula. So then they'll ask you then to answer a question. It says a lunar landing craft weighs 2,449 kilos on the moon. Calculate the weight of the landing craft on the Earth. So if m is 2,449 kilos, find e. And we just substitute that in. So 2,449 equals e divided by 6. In other words, 2,449 times 6 equals e. So e is 14,694 kilos. Okay. This question is worth 2 marks. So it'll be a mark to work out the formula and a mark to work out the answer here. Okay. This is a very simple proportion question because it's direct proportion and it's direct linear proportion. It could actually be done in one step, really. So where you've got your moon and your Earth, it's like we do capture recapture. So we want the ratio of moon over Earth. We know that 14 kilos on the moon equals 84 kilos on Earth. And the second bit said that the lunar landing craft weighs 2,449 kilos on the moon. So 2,449 on the moon, and what is the weight on the Earth? Now we know that x is on the denominator here, so we're going to flip both sides. So 84 over 14 equals x over 2,449. And so therefore 84 over 14 times 2,449 will equal x. And we should get 14,694. So 84 divided by 14 times 2,449. And we do get 14,694 kilos. But this you would only use for direct linear proportion. And next week we'll be looking at indirect and non-linear as well. So you could only use this for direct linear proportion.